Today we will discuss about question number 7 and 8, exercise 8.1. In this chapter we are having some concept. Out of these concept, this exercise 8.1 is based on trigonometry ratios. We are having 6 trigonometry ratios: sin theta, cos theta, tangent theta, and reciprocal of these trigonometry ratios will be what? Reciprocal of this one, sin theta, will be what? Cosec theta. Reciprocal of cos theta will be sec theta. Reciprocal of tangent theta will be cot theta. Clear? And this is the right triangle, and in the right triangle we are having one angle 90 degree, and opposite this one is what? Hypotenuse. And right triangle having two acute angles. Once we take this acute angle, then its opposite side will be what? Perpendicular, and its adjacent side will be what? Base. Clear? Once we take this acute angle, once we take this one as acute angle, then its opposite side will be this one, and this is what? Perpendicular, and its adjacent side will be this one, and it is what? Base. Clear? This is the difference between acute angles. Take this one, then this will be perpendicular. Take this one, then its opposite side, this will be perpendicular, and adjacent side will be what? Base. Clear? So in the question number 7, we are having cot theta. One ratio we are having. Cot theta equal to 7/8, 7 upon 8. We want to evaluate these questions. So in these questions we are having sin theta, cos theta, cot theta. Clear? Already cot theta value we are having, so we can easily to find this one, no problem. But in these two we are having sin theta and cos theta. So by using this trigonometry ratio, can we find sin theta or cos theta? Yes, by using one trigonometry ratio we can find remaining trigonometry ratios. Clear? So by using this ratio, first we will find ratio of sin theta and cos theta. Clear? How we will find? From this ratio we are having two sides of the right triangle, and right triangle having three sides, so remaining side we will find by using the Pythagoras theorem. In this way we obtain all the sides, then we can find sin theta and cos theta. Clear? Any trigonometry ratio we can find from the one trigonometry ratio. Clear? Observe. What is the question? Question number 7. What will be its solution? What is the given? We are having cot theta. What? Cot theta equal to 7 upon 8. It is the given in the question. We know well cot theta is what? Reciprocal of tangent. Tangent theta is perpendicular upon base. Its reciprocal will be what? Cot theta. So cot theta equal to what? Base upon perpendicular. So we can say base upon perpendicular equal to 7 upon 8. When comparing this equation, what we are getting? Base equal to 7 and perpendicular is what? 8. Yes or no? I am drawing right triangle. Observe. This is the right triangle in which we are having, I am taking as a ABC, B as a right angle, it is acute angle I am taking. Its opposite side will be perpendicular, and its adjacent side will be what? Base. So what is the value of perpendicular? Perpendicular is 8, and this one is what? 7 units. So from this given ratio we can write the two sides of right triangle. Now this is what? It is opposite of 90 degrees, so it is what? Hypotenuse. We don't know this one, but by using Pythagoras theorem, from Pythagoras theorem we can obtain this side. Yes or no? Pythagoras theorem gives a relationship between these three sides. H square equal to hypotenuse square equal to base square plus perpendicular square. So we can say what? h square will be base is what? 7 square plus perpendicular is what? 8 square. So what we can say? H square equal to 7 square will be 49 plus 8 square will be 64. Add both. H square equal to what? 9 plus 4 13, 1 is remaining, 6 plus 4 10, 10 plus 1 11. So h square what? H square we are having 113. So h will be plus minus square root of this one, but it is the length, so we will consider what? Positive value. Square root of 113 is what? Hypotenuse. So in this way we obtained the remaining side of right triangle. In the question from this ratio we are having two sides, and remaining side we can obtain by using Pythagoras theorem. We obtained. Now what we want? We want its result. So how we will obtain this result? Observe. What is the first one? First question is what? 1 minus sin theta, 1 plus sin theta into 1 minus cos theta divided of 1 plus cos theta, 1 plus cos theta, this is what? Sin theta. 1 plus cos theta into 1 minus cos theta. Clear? 1 plus sin theta into 1 minus sin theta divided of 1 plus cos theta into 1 minus cos theta. By observing we are getting this is in the form of a plus b into a minus b. So we know well a plus b into a minus b is what? A square minus b square. So we can write this one 1 square minus sin square theta upon 1 square minus cos square theta. Clear? So we want what? This can be written as 1 minus sin square theta upon 1 minus cos square theta. Observe, what is the meaning of sin square theta and cos square theta? Sin square theta is what? Sin theta whole square. Sin square theta is what? It is the same as sin theta whole square. So we know, once we know the value of sin theta, we will put there and we will square, and that will be the result. So sin theta and cos theta, so this can be written as 1 minus sin theta whole square upon 1 minus cos theta whole square. Yes or no? We are having all sides of trigonometry. Can we find sin theta and cos theta? Can we find? Yes or no? Yes, we can find. 1 minus, this is what? 1 minus cos theta whole square. Now for evaluate its value, we require sin theta and cos theta. From this this is the right triangle. Can we obtain sin theta or cos theta? Yes, we can obtain. Any ratio we can obtain once we are having all three sides. So what will be the value of sin theta? Sin theta will be perpendicular upon hypotenuse. So its value will be what? Perpendicular is what? Perpendicular upon hypotenuse is sin theta. In this diagram we are having perpendicular is 8 and hypotenuse is what? We obtained square root of 113. And what about the cos theta? Cos theta equal to base upon hypotenuse. So its value will be, base is 7 upon square root of 113. Yes or no? We want its value. So it is in the form of 1 plus a plus b into a minus b, and a plus b into a minus b will be what? A square minus b square. So this can be written as 1 square minus sin square theta. Similarly, this can be written as 1 square minus cos square theta. Clear? Sin square theta is what? This is sin theta whole square. Sin square theta will be what? Sin theta whole square. And cos square theta is what? Cos theta whole square. Now to solve this one, we want sin theta and cos theta. How we will find this value? We are having right triangle, and in this we are having all sides, so we can easily to find these two ratios. Clear? Put these two values in this question, then what will be the result? Observe. 1 minus sin theta is what? Sin theta is 8 upon square root of 113 whole square, divided of 1 minus cos theta is what? 7 upon square root of 113 whole square. Clear? We are putting sin theta and cos theta values. Now we will solve this one. 1 minus 8 square is what? 64. 8 square is what? We are putting right value or wrong? 8 square is what? 64. Divided of what will be its square? Square root of 113 square we want. So how we will solve this one? 113 power 1 by 2 and its power 1 by 2. So what will be its whole square? So whole square, how we will find? A power m whole power n. Laws of the exponent will be applied there. So this can be written as 113 and both will be multiplied 1 by 2 into 2. So this will be 113 power 2 upon 2, or this is 113. So we can say 8 square is the 64. Square root of 113 square will be what? 113. Now in the denominator what we are having? 1 minus 7 square is 49 and its square is same this one, 113. Clear? Now take LCM. How we will solve? Now we want its LCM. So I am taking this one. This is the numerator and this is the denominator. So we will take LCM in both. So what will be the LCM in the numerator? We are having 113 is the LCM and there is the 1. So 113 is divided of 1. How many times it is going? 113 times it is going, and result will be multiplied by numerator. So what will be the result? There will be the 113 minus this divided by this one time it is going, multiplied by numerator 64. This divided of now this one, what will be this one? Its LCM is what? 113. There is 1. How many times it is going? 113 times it is going, and result will be multiplied by numerator. Then this is 113 minus this divided by this one time it is going, multiply by numerator, and this will be what? 49. Clear? Now observe, subtract this one. This is what? 113. 3 minus 4. So we cannot subtract. So we are borrowing 1. 13 minus 4 will be what? 13. 13 minus 4 will be 9. There is a 0. We cannot subtract. Borrowing 1. 10 minus 6 will be what? 4. 10 minus 6 will be 4. In the denominator we are having 113. And now take this one. What will be the subtraction? 13 minus 9. 13 minus 9 will be what? 4. Now there is a 0. We cannot subtract. So 10 minus 6 will be 10 minus 4. 10 minus 4 will be 6. And in the denominator we are having this one. So how we will solve this one? Yes, we can solve 49 upon 113 into this can be written as 113 upon 64. So this to this will be cancelled. We are getting 49 upon 64. So what will be the result of this question? This question is having 49. This question is having what? 49 upon 64. So what will be the value of this one? 49 upon 61. Observe, again I am solving, revising. What? Observe, easy question, not a hard question. We are having one ratio. What ratio we are having? Cot theta we are having. From this ratio we can obtain remaining side. Cot theta is the b upon p, base upon perpendicular. So we are having base equal to 7 and perpendicular equal to 8. base equal to 7 and perpendicular equal to 8. We want h, so how we will find? We will use Pythagoras theorem. We are solving, we are getting this one. Clear? Now question number one is what? This one. And this question is in the form of a plus b into a minus b, and it is what? A square minus b square. Algebraic identity we are applying. Similarly in the denominator we are applying same identity. Clear? Then we can write 1 square minus sin square theta upon 1 square minus cos square theta. This is the 1 minus sin square theta upon 1 minus cos square theta. Cos square theta means what? Sorry, sin square theta means what? Sin theta whole square. Cos square theta means what? Cos theta whole square. Clear? This is also important. Now we want the value of sin theta and cos theta. We are having all trigonometry ratios. We are having all sides of a right triangle, so we can find any trigonometry ratio. So we can find sin theta and cos theta. Sin theta is p upon h and cos theta is b upon h. We are having all sides of this triangle, so we can obtain. We will put these value there. Then we are solving, and we are getting what? 49 upon 64. This is the process. But once you studied this chapter, trigonometry is completed. All three exercise 8.1, 8.2 and 8.3. Then we can do this question in another way also. How? In the exercise 8.3 is based on the trigonometry identities. Exercise 8.3 is based on the trigonometry identities, and we are having three trigonometry identities. Observe, we are having three trigonometry identities. First one is sin square theta plus cos square theta equal to 1. Second one is 1 plus tangent square theta equal to sec square theta. 1 plus cot square theta equal to cosec square theta. We are having these three trigonometry identities, and by using these identities we will solve questions of exercise 8.3. So once we completed this chapter, then we will having some knowledge, then we will apply that knowledge, and that question can be solved. How? Observe this one. Till we will do same, but observe this one. 1 minus sin square theta is what? 1 minus sin square theta is what? This is, observe. After this one, how we will do? Observe this one. After this one, what we will do? 1 minus sin square theta is what? From this identity, what we can write? From this one, we can say what? Cos square theta equal to 1 minus sin square theta. Yes or no? And sin square theta equal to 1 minus cos square theta. Observe carefully, not hard, easy question. What we are doing? After this one, by using these identities we can solve. We are having first trigonometry identity sin square theta plus cos, sum of the sin square theta plus cos square theta equal to 1. And this can be written as, from this, once we find the cos square theta, then what we are getting? We are transposing sin square theta towards the right, then 1 minus sin square theta. And 1 minus sin square theta will be what? Cos square theta. So at the place of the 1 minus sin square theta, we can put cos square theta, yes or no? Yes, we can put. So what we are putting? At the place of 1 minus sin square theta, we can put 1 minus sin square. 1 minus sin square theta is cos square theta. What? Cos square theta. And at the place of the 1 minus cos square theta, 1 minus cos square theta, we can put sin square theta. Yes or no? Sin square theta. Clear? Sin square theta. And this can be written as what? Cos theta whole square, and this one is what? Sin theta whole square. And this is what? Cos theta upon sin theta whole square. And this is what? Cos theta upon sin theta is what? Cos theta upon sin theta. Tangent theta is sin theta upon cos theta and its reciprocal will be cot theta. So cos theta, cos theta to sin theta ratio is what? Cos theta to sin theta ratio is what? Cot theta. So cot theta whole square. So this will be what? Cot theta, cot square theta. And what value we are having? Cot theta equal to 7 upon 4. What value? Cot theta equal to what? And directly we can write cot theta is what? 7 upon 8. And its whole square will be what? 49 upon 64. Yes or no? This is same or not? We are obtaining what? Same result? Observe what we are doing. That time we are studying exercise 8.1. So that's okay. Once we complete this chapter, then we understand these identities also. Only 3 identities we are having. It is the introductory part. So in the next class, in this higher classes, you will discuss more, you will study more identities. So in your standard, we are having only these 3 identities. So using this identity, sin square theta plus cos square theta equal to 1. So we can say cos square theta will be what? 1 minus sin square theta, and sin square theta will be what? 1 minus cos square theta. Yes or no? Once we transpose, we can find these two. And now 1 minus sin square theta is there. So we can put there what? Cos square theta. 1 minus cos square theta in the denominator. So we can put sin square theta. So we are putting what? Cos square theta upon sin square theta. After this one, we can do this one. Then cos theta, or this can be written as what? Cos square theta. Cos square theta is cos theta whole square. Sin square theta is sin theta whole square. We are putting. So this will be what? Cos theta upon sin theta whole square. If whole square we are having, then what we can do? Numerator square upon denominator square. So this is cos theta to sin theta. From first class onwards, we are studying these ratios, these types of the ratios. Tangent theta is sin theta upon cos theta. Cot theta is the reciprocal of tangent 1 upon tangent theta, and it is what? Cos theta upon sin theta. So we will apply there. Cos theta upon sin theta will be what? Cot theta. Cot theta whole square. Now what is the value of cot theta? It is given in the question. It is given in the question. Cos theta is this one. Cot theta is this one. We will put cot theta equal to 7 upon 8, and its whole square will be 49 upon 64. And directly without this calculation, we are getting this one by using trigonometry identity. So you can follow any process. It depends on you. Once you perfect, then you can do. That time you can follow this one. Clear? Now, next question is what? Cot square theta. Observe this one. Cot square theta. This one is this question. Cot theta whole square is what? Cot square theta. Cot square theta can be written as what? This is an easy question. Observe, we can do there. Question number 7, second one I am taking. What is this one? Cot square theta. We want its value. Observe. Easily we can do. We already know sin square theta can be written as what? Sin theta whole square. Same way we can write all the trigonometry ratios. So this can be written as what? Cot theta whole square. Now what is the value of cot theta? It is given in the question. Cot theta is 7 by 8. So put the value of cot theta 7 upon 8. And its whole square will be there. So 7 square is what? 49. What is the 7 square? 49. 7 square is 49 and 8 square is the 64. Both questions, question number 1 and question number 2 of 7th one, we are having same answer. It is also having what? 49 upon 64, and this one is also having 49 upon 64. So what we are doing? Observe, in the question number 7, we are having one ratio. We want to evaluate this one. So in this second one, we are having cot square theta. And what is the meaning of square, sin square theta is sin theta whole square, so cot square theta can be written as cot theta whole square, and value of cot theta is the given in the question. We will put there and solve, then we are getting the answer. And in which, in the first one we are having a plus b into a minus b form, so we will use a plus b into a minus b will be what, a square minus b square, algebraic identity. Then this can be written as like this, 1 minus sin square theta upon 1 minus cos square theta. So sin square theta and cos square theta can be written as like this. Now for solving this one, we want sin theta and cos theta, so we will find these values. How we will find these values? We use first Pythagoras theorem. Why Pythagoras theorem we are using? Because we, from this one we are having two values, but we want the third side also. Then we will use this one and we will find this one. Once you complete this chapter, then no necessity to do this one. We will use directly this one. What? Trigonometry identities. By using trigonometry identity first, we can write 1 minus sin square theta is cos square theta, and 1 minus cos square theta will be what? Sin square theta, and cos square theta upon sin square theta will be what? Cos theta whole square. This upon sin theta whole square, this will be what? Cos theta upon sin theta whole square. So this is the cot theta whole square. So cot theta value we are having, so no necessity to find these all, directly we can solve. So I completed both the methods. You can follow as you are feeling good. Clear? Now question number 8th one. Observe what is this one. Question number 8th one, what I am taking there. Question number 8th, we are having again one trigonometry ratio. By using that trigonometry ratio, we will what? Want to show. We want to show this one. Check whether this one is correct or not. So we are having, what is the given? Question number 8th I am taking. Given. What is the given? We are having 3 cot A equal to 4. 3 cot A equal to 4. So this can be written as cot A equal to 4 upon 3. And what is the cot A? Cot A is the reciprocal of tangent A. Tangent A is P upon B. Cot A will be B upon P. B upon P will be what? 4 upon 3. So from this equation we can say B equal to what? 4 and P equal to what? 3. Clear? So in which we want to show, so we require the third side also. So I am drawing a diagram. B is, I am taking, this is a acute angle, A is a acute angle, this is the B is 90 degree, its opposite will be hypotenuse, and this is C. So its opposite will be perpendicular and it is equal to 3 units, and base is what? 4 units. Clear? How we will find this, and why we are finding hypotenuse? Because we want to show this one, and in which we are having tangent A. We are having cot A, we want tangent A, cos A and sin A. Then we can prove. So we want to find, so we require all sides of the right triangle. We are having 2 sides. So we will find third one how? From Pythagoras theorem. From Pythagoras theorem. And it gives the relationship between h square, hypotenuse, base and perpendicular. H square equal to base square plus perpendicular square. Now what is the hypotenuse square? Will be base is 4 square plus P is 3 square. Solve carefully. Base is what? 4. So this will be 4 square will be 16 and 3 square will be 9. So 16 plus 9 will be 25. And this is the value of h square. So what will be the value of h? H will be the square root of 25. We will consider positive value. So its value will be what? H equal to 5 will be the answer. H will be what? Hypotenuse will be what? 5. So we obtain all the sides of the right triangle. Now in the questions we require 3 trigonometry ratios. First, sin A I am taking. What will be the sin A? Sin A is the ratio of what? Sin A is what? Perpendicular upon hypotenuse. And what will be its value? Perpendicular is 3 and hypotenuse is what? 5. Now next one, cos A will be what? Cos A will be base upon hypotenuse. What will be the value of base? Base is 4 and hypotenuse is 5. And one more we have want tangent A. And what will be the tangent A? Tangent A will be perpendicular upon base. What is the ratio of tangent theta? Tangent theta is what? Perpendicular upon base. So this will be what? Perpendicular. Perpendicular is 3 and base is 4. Perpendicular is 3, base is 4. When A is a acute angle. Clear? Now in this question I am writing there what we want to check. 1 minus tangent square A upon 1 plus tangent square A will be cos square A minus sin square A. We want to check. So this one is having what? 3 sides, not 3 sides. This is having 2 sides. This is the what? Left hand side and this one is what? Right hand side. Clear? Left hand side and right hand side. So we will prove, we will take one at a time and we will check, and if both left hand right hand values are equal, then we can say this relation is correct, otherwise not. Are you getting what I am saying? We are having this equation, we want to say this is equal to this one or not. How we will say? We will solve this side, we will put the value of tangent A and tangent A from this one, from these values, and in which also we will put values of sin A and cos A. If left hand is equal to right hand, then we can say this relation is correct. So one by one I am solving. Left hand side I am taking first. So what is the left hand side? 1 minus tangent square A upon 1 plus tangent square A. Now this can be written as what? 1 minus tangent A square upon 1 plus tangent A square. Clear? Put the value of tangent A. What value we are having? We are having the value of tangent A is 3 upon 4. So we can say 1 minus 3 upon 4 square upon 1 plus 3 upon 4 square. Solve this one. How we will solve? 1 minus 3 square is 9 upon 4 square will what? 16 upon 1 plus 3 square is 9 and 4 square is 16. Clear? Take LCM and solve. What will be its LCM? In the numerator and denominator we are having same LCM. 16 is LCM. 16 times it is going multiplied by 1. We will multiply both. Multiply by 1. So 16 minus 1 time it is going multiply by numerator 9. It is the numerator value, and in the denominator what we are getting? 16 will be the LCM. 16 time it is going multiply by 1. 16 plus 1 time it is going 19. This is what? Denominator value. Solve this one. 16 minus 9 is what? 16 minus 9 is 7. 7 upon 16 divided of this is 25 upon 16. So how we will write this one? This can be written as 7 upon 16 into 16 upon 25, and finally we are getting 7 upon 25. So what is the value of this one. This is the left hand side. This is the value of left hand side. 1 minus tangent square a upon 1 plus tangent square a is what? 7 upon 25. This is the value of left hand side. Now I am taking right hand side. I am solving there. Right hand side value will be what? I am taking this one. What is this one? Cos square a minus sin square a. What is the value of cos a? This can be written as what? Cos a whole square minus sin a whole square. Observe carefully, you can do easily. Cos a is 4 upon 5 whole square minus sin a is what? 3 upon 5. 3 upon 5 whole square. Solve. 4 square will be 16, 5 square will be 25. Minus 3 square will be 9 and 5 square will be 25. Take LCM. What will be LCM? 25 will be LCM. One time it is going, multiply by 16. 16 minus one time it is going 9. So what will be the remaining? Remaining is 16 minus 9 will be what? 7. 16 minus 9 will be 7 upon 25. It means what we can say? Right hand side, what we are having? Once we solve the left hand side, then we are getting 7 upon 25 and right hand side also having 7 upon 25. So finally we can say left hand side equal to right hand side. So this, what we want, if this 3/4 equal to 4, check whether 1 minus tangent square a upon 1 plus tangent square a equal to cos square a minus sin square a or not. So left hand side equal to right hand side. So this is the correct equation. 1 minus tangent square a upon 1 plus tangent square a will be what? This can be written as what? Cos square a minus sin square a. This is the one identity we will discuss later. It is not in your standard, so in which we want only this is the expressions, we want this expression is equal to this one or not. So we are solving how? By using trigonometry ratio. So in which we require tangent a, we can obtain tangent by using given one ratio. Remaining in which we want sin a and cos a, we can find sin a and cos a ratios by this one. And we obtained left hand side and right hand side equal, so we can say this is correct equation, or we can say this is equal to 1 minus tangent square a upon 1 plus tangent square a equal to what? Cos square a minus sin square a. Both are equal, we can use both one. Clear? So in this class we studied question number 7 and 8. Both are based on trigonometry ratios. That's all about this class. Thank you so much.